Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example. Another one dealing with sequences, series. So here we're told that the 11th term of an arithmetic sequence is 15, and the common difference is -5/4. And then two parts to this, so we have to find what the 30th term is going to be. And then in part B, we have to find the sum from the 11th term to the 20th term, right? And I'll expand on what the sigma means and stuff in part B later. Once we get there, let's focus on part A for now. So this is an arithmetic sequence. So what are we given? We're given the 11th term. So we're given A11 is equal to 15. And we're told that the common difference is -5/4. And what they're asking us in part A is what's A30 going to be. Now, there's actually multiple ways to do this. The first way that I'm going to do it is actually my preferred way. It's actually a little bit longer, but I prefer to do it this way because in the second way, there's more potential for mistakes. Even though it's a shorter way, there's, in my opinion, higher risk of making mistakes with the numbers and stuff, and I'll explain why when I do the second way. The first way is going to be a little bit longer, but it's more of like a standardized process, which I like. So I always prefer, even if it takes a little bit longer, if I could have a standardized process that I could apply to more questions. I always take that way versus taking certain questions and then manipulating them in a certain way. If you are super comfortable with sequences and series and that's the way you do it, whichever way you do it, I mean, you could pause the video here, try it yourself, see if you're getting the same solution that I'm gonna get. But yeah, I will show you two different ways, but the first way is gonna be my preferred way. And basically, to find a term in an arithmetic sequence, this is the formula that we use, right? This is the standard formula. And the two main parameters for an arithmetic sequence are the d value, which we already have, -5/4, and the first value of the sequence, A1, which we don't have. We have the 11th term, right? So what we're going to do is we're going to use this information knowing that the 11th term is 15. I'm going to plug in all the parameters here, and I'm actually going to solve for what the first value should be, because the two main parameters, again, for an arithmetic sequence are the d value, which we have, -5/4, and the A1 value, which we don't have. For a geometric sequence, the two main parameters are A1 and the R value, right? The common ratio. Again, we're not dealing with geometric sequences here in this question, but thought I would mention. So those are always the two parameters that I try to get, because then everything becomes a lot easier, and then I could just plug and play and whatever I'm trying to solve. So let's use this information. So the 15th term, the 11th term is 15. We're solving for A1. Common difference is -5/4, right? It's going to be like plus -5/4, which just ends up being -5/4. And then this is going to be, this is the 11th term, so n is 11 minus 1, like that. So we'll end up with 15 equals A1 minus 5/4 times 10. And then -5/4 times 10, that simplifies to -25/2, right? You'll have 50/4, simplifies to 25/2. Then bring the -25/2 over, so I'll have 15 plus 25/2 is A1. So that means A1 is going to be, this would be what, 30/2, so 55/2, like that. So that right there is the first term for this arithmetic sequence. So now we have our two main parameters. A1 is 55/2, the d value is -5/4, and now we could go into finding what the 30th term is going to be, right? What they're asking us for here, which is going to be the first term, 55 over 2, plus the d value of negative 5 over 4, and then we're looking for the 30th term, so the end value is going to be 30, like that. And then when you do all of the algebra here, right, multiplying these two terms, you get 145 over 4, then subtracting these two fractions, you end up with negative 35 over 4. Okay, so that there is going to be the answer for part A. Now, what's this other way that I was mentioning before that we can do? What we can do is instead of finding A1, so let me try to first write this out. So instead of finding, let me think how I'm going to show this. So instead of finding A1, like we did, this 55 over 2, what we could do is we could start the sequence at the 11th term. So we'll have A11, A12, A13, etc., 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 all the way to A30. That's what we're looking for, right? We're looking for A30. So what we could do is we could start the sequence here with A11 being the first term. Then this is going to be the second term. This is going to be the third term. And now here's where like some mistakes can come in when you're doing it this way. A lot of students, if they'll do it this way, because we have to figure out if we're going to start a new sequence, right, at A11, which term is going to be A30. And a lot of times what students will do is they'll take 30 and minus 11, which is 19, and they'll say, okay, that's the 19th term. Okay, but that's actually not going to be correct, because if we applied that logic or that process here, well, 13, A13 minus A11, 13 minus 11 is 2, but notice that A13 is the third term. And the reason is because we're including this, right? If you subtract this 13 minus 11, you're not including that 11, so that's why you get that 2. Right? You get these two terms. However, the A11 is being included. That's the first term of the sequence. So to get that proper term number, it's like 13 minus 11, which is 2, but then you got to add 1 to get the proper term number here, right? Because it's inclusive of the A11, right? So it's like 30 minus 11 is 19, but then you have to add 1 here. So that's actually going to be the 20th term. Okay, and that's why this is not like my preferred method, because it could start being a little bit hectic with the numbers. Just make sure that if you do it this way, just be super careful that you're not just taking like this term or that number 30 and subtracting 11, right? So even just from this explanation, hopefully you're not confused. I'm doing my best to explain it here. But what we could do is we could start a new sequence here, right, with pretending that the first term, you know, and let's actually maybe not use A. Let's pretend that we're using T, right? So the first term of this new sequence is going to be the 15. The common difference is still negative 5 over 4, and what we're looking for is the 20th term in this sequence, okay? Not the 30th of the sequence where we had the first term being 55 over 2, the common difference being negative 5 over 4. The common difference is staying the same, right? You keep subtracting negative 5 over 4 to get to the next term. It's just the term numbers are different, right? Because now this A11, this value of 15, is the first term of the sequence, and then we have to find the 20th term, which is going to be the A30. And so notice that, right, it's a lot less if we use the sequence formula, so it's going to be 15 minus 5 over 4 times 20 minus 1. And then that's the only calculation right? So it's a lot less calculating because we don't have to find A1 like we did before and then use that A1 in the sequence formula. But again, I just feel like the other way, it's a more standardized process where you don't have to worry about these numbers and getting these numbers right and saying where's the first term of the new sequence going to start, where's the last term going to be that we're looking for, right? The other way is a little bit longer, but it keeps everything nice and standardized versus doing it this more shorter but maybe less intuitive way. That might be the right way to describe it. But either way, if you do it this way, you should get the same answer. And if you actually go through the algebra, 20 minus 1 is 19, multiplying those, 95 over 4, subtracting these, you do indeed get negative 35 over 4. Right? Same answer that we got when we did it the other way. All right, so whichever way you want to do it, whichever way you prefer, make sure you're getting the same value. Either way, for part A, the answer is negative 35 over 4. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. Now moving on to part B, what they are asking us to do here is find, now what this is basically this sigma represents the sum, and we have a counter starting at an I value of 11 and stopping at 20. So this is basically a sum here. So what's happening is we're starting at 11, so it's going to be A11 plus, and then we go to the next counter, right? So I equals 11, next counter is going to be 12. We go up by 1 always, right? So A11, then A12, then A13, then A14, etc., etc. And we're going to stop at this value here, A20, like that. Okay, so they're basically asking here, what's the sum in this arithmetic sequence from the 11th term to the 20th term? Okay, that's what they are asking us for here. Now, like in part A, there's different ways to do this. This one in particular, I'm actually going to start at A11 being the first term of this series. Now, we know that a series, right? There's two formulas for an arithmetic series. We have n over 2, and then it would be a1 plus an, like that. Or n over 2, 2a plus d bracket n minus 1. And I'm going to actually use this second one here, because with this one, what we would first, in order to use it, we would have to find what the 20th term is going to be, and then plug it in, and then be able to use this formula. Versus here, we're already going to have all the parameters that we need to just directly plug it in. Now, what we can do, okay, one way to do it, which is not the way that I'm going to do it, but I will mention it first, and then I'll do it the previous way, is, okay, let's pretend that this is not starting at 11. Let's say it's starting at 1. Right, and then we have A2, and then it's going to keep going, and then let's say that we're going to have like A10, A11, okay, that's going to keep going all the way to A20. So one thing we could do to get this sum here is we could take the sum of all 20 terms starting from A1. So we could take S of 20, and what we could do is we can subtract, let's do it in a different color here. We could subtract the sum of the first 10 terms, like that. And what's going to be left over, right, if we take this entire green expression, subtract this blue expression, well, we'll be left with this expression from A11 to A20, which is what we're looking for. Okay, so that's one way to do it. So find the sum of the first 20 terms starting at A1, and then subtract the sum of the first 10 terms. Okay, so we can do it like that. You know what? Let's actually do it like that, and then I'll do it the second way as well. Let's just take the time to show both ways, just so you could feel you could figure out on future questions which way you want to do it, and you can see how we're going to get the same answer. So if we do find, let's find it over here. So we'll have to find both of these terms separately, right? So we're going to have to find S of 20. Now S of 20 is going to be what? Using that formula that I just erased here. So 20 over 2, 2 times 55 over 2, minus 5 over 4 times 20 minus 1, like that, right? That's the formula for the series, for an arithmetic series, and that's for the first 20 terms there. And so when you do all of the algebra here, right, taking the 10 here and then simplifying this bracket, 55 minus 95 over 4, multiply everything, you'd end up with 625 over 2. So that's, again, the sum. Let's maybe keep this all color coordinated. That's the sum here of the first 20 terms, like that. Okay, and now what we're going to have to do is subtract the sum of the first 10 terms. And so the way we would do that, again, plugging it in the formula, so n over 2, 10 over 2 this time. 2 times the a value is still that 55 over 2, minus 5 over 4, but now the bracket's going to be 10 minus 1, like that. And so when you do this, you'd end up getting 875 over 4. So that's going to be the sum of the first 10 terms, right? That's going to be this over here, 875 over 4. And then the difference between those is going to give us this right here, right? That's what we're looking for, the sum from the 11th term to the 20th term. So when you get a common denominator, subtract these, you'd end up with 375 over 4, like that. So that's what the final answer is for part B. Okay, so that's one way to do it, right? The sum from the 11th term to the 20th term, one more time, is basically the total sum of all 20 terms from 1 to 20, subtracting the sum from 1 to 10. And the remaining is going to give us that 11 to 20. And again, the advantage of this way, it's a little bit longer because we have to find two sums, but it allows us to stay with these parameters, where that first term that we already solved for in part A is 55 over 2, common difference is negative 5 over 4, and we don't have to worry about changing this series, like the first term is going to be A11, then what's the A20 term going to be, and then trying to play around with the numbers like that, right? You could do it like this and get the final answer of 375 over 4. Now, if you were to do it this other shorter but less intuitive way, the A11, that would be like the first term again, like we did in part A, right? That's going to be our first term. This is going to be our second term, third term, fourth term, etc. Question is, A20 for this new sequence that we have, or this series, because we're adding everything, which term is that going to be? Well, notice that, let's say, if we take 14 minus 11, that gives us 3, but notice that A14 is the fourth term, so we have to add 1, right? So using that same pattern, 20 minus 11, 9, plus 1, that's going to be the 10th term, right? So there's actually 10 terms in this new sequence, in this new 1 sequence that we're going to be doing. So T1 is going to be 15, right? A11 is 15, if you remember. there are 10 terms, and the common difference is still -5/4, right? So plugging that in, basically the sum of these 10 terms is going to be 10/2, right? N/2, 2 times 15, 2 times the first term of this new series, minus 5/4, bracket 10, minus 1, like that. And when you end up doing all this algebra, right, this bracket here is going to be 30 minus 45/4 multiplied by 5. You'd end up with that same solution, 375/4, that we got when we did it the other way. All right, so again, multiple ways to do this. I know this this video took a little longer because I wanted to show you multiple different ways to do this. In order for you to get comfortable seeing different ways, and then you figure out your own style with how you want to do it. Again, whichever way you do it, as long as you're getting the same values that I am, then it's all good. All right, and that's pretty much a wrap for this question. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.